So in this section, we are concerned with statements which involve symbols such as greater than. So this means greater than, e.g. 6 is greater than 2. Then we have that one meaning less than. Then we have one greater than or equal to. Then there's one less than or equal to, meaning so statements containing these symbols are called qualities. You cannot hear me? Members, you cannot hear me? Can you hear me? Yeah, so someone is saying I'm inaudible. So statements containing these symbols are called inequalities. For example, x is less than 2, x is greater than or equal to 2, y is less than or equal to 2, y is greater than 10. These are inequalities. So we can look at some of ways in which we can manipulate these inequalities. So to illustrate this on a number line, you plot just like the way you plot This means x is greater than 3. So you draw that stroke at 3. You don't shade that circle, meaning that you are not including the 3. You're not including the 3. If it is greater than or equal to, would include the 3. But because it is not, you're not including it. That is how we illustrate this. X is greater than 3. If you have x is less than or equal to minus 3, so that includes that. So that circle is shaded. So all these numbers are numbers where x is less than or equal to -2. These are a range of numbers, okay? It's not just one number, it's a range of numbers that satisfy the given inequalities. That is why our answer is not just one number. It's not equal to, so we have a range of them. That is the symbolic nature of inequalities. They are a range of numbers that we are dealing with, not just one number. So we can look at compound statements. So these are statements which can be combined to give you one statement of the form x is greater than a or less than b. Write the following. So if we have to write this one, If you combine it, x is less than or equal to 3 and x is greater than or equal to 3. If we have to write it in this format, then you can see we place x right in the middle of that. Then x is greater than minus 3. And it is less than or equal to 3. If we put it on a number line, we have 0, 1, 2. So x is greater than, but less than or equal to. Okay. This is the region number line satisfies. Where it is greater than only, we don't shade the circle there. When it's less than or equal to, we shade the 3. So that is the way you represent that inequality. So we combine that. X is always in the center. X is less than 2. X is greater than -1. And if we represent this, we'll have x is greater than -1, but it is less than 2. So we're looking at solutions of linear inequalities in one and one. So solve the following inequalities. So here we just solve it the normal way we solve an equation, but having in mind that it is an inequality. So we'll have put the like terms together. We'll have x being greater than 11 minus 5. X is greater than 6. Here we put the like terms together. We have divide this side by 2. We also put the like terms together there. We subtract 5 from both sides. One side we get 0. On this side we get 14 minus 5. 1 over 4x 9. Multiply both sides by 4. So if you look at some examples where you have 8 is less than 10, you multiply this side by -4 and multiply this side by -4, you get -32. And the inequality sign there is less than. But you can see that -32 is not less than -40. So for this to be true, we have to change that inequality sign to greater than. Otherwise, it will be false. Same applies to division. If we divide 8 by -4, this will give us -2 being less than -2.5. And we know that -2 is not less than -2.5. So that means whenever we are multiplying or dividing using negative numbers, we reverse the inequality signs. Otherwise, they will not be true. So multiplication and division of inequalities by negative numbers reverses the inequality sign. We've seen that. It reverses the inequality sign. solve the inequality 3 minus 2x is greater than or equal to 15. We will subtract 3 from both sides. So we have minus 2x is greater than or equal to 15 minus 3. If we subtract it from the left-hand side, we get 0. Then you divide this one by minus 2. Divide what you get by minus 2. X will be less than, we reverse. Once we're dividing by the negative, we reverse. 12 divided by minus 2. So that will give us our x being less than or equal to minus 6. Then we can look at solving simultaneous inequalities, or pairs of simultaneous inequalities. So we solve the first one, then we solve the second one, then we combine the two. Therefore, we have 3 minus x is less than 5, minus x is less than 5, minus 3. And then we divide this by minus 1, minus 1. And we change, once we divide that, we change. We have x will be equal to minus 2. X will be greater than minus 2. Remember, we are changing the, we are reversing the sign because we are dividing by a negative. Then you have 2x is less than 7 plus 4. Then we have divide this by 2. X will be less than 12 divided by 2 is 6. So if we are combining these two, we know that x is greater than minus 2, but it is less than 6. We put x at the center. X is greater than minus 2, but it is less than 6. We want to plot this, you can plot it. So x is greater than minus 2, but it is less than 6. So we open the bracket. We have 2 plus 2x plus 3x minus 6 is greater than or equal to 25. When we put the like terms together, we have 5x minus 4 is greater than or equal to 25. 5x is greater than or equal to 29. 25 plus 4. And x will be greater than or equal to 29 divided by 5. So if we plot this on a number line, that will go there 5 times 8. So 5.8 is someone, I think. And it includes the greater than or equal to. So that will be our number line. If this is 1, 6x plus 2 is less than 3x plus 8. We split them. If they are like that, we split them. We'll have 6x plus 2 is less than 3x plus 8. You solve this one first. That will give, and then we also split 3x plus 8 is less than 27x minus 1. So the first one will give us, put the like terms together, bring 3 on this side, 3x. We have 6x minus 3x is less than 8 minus 2. 2x is less than 6. X is less than 2. The second one, you have 3x minus 27x is less than minus 8. So less than minus 1 minus 8. So that gives us minus 24. X is less than minus 9. Divide by minus 24. We will change inequality. Gives us, 3 will go here, that will cancel. 3 will go here, 3. 3 will go here, 8. That is 3 over 8. If you have to represent these on a number line, first of all, you combine them. You have x being greater than 3 over 8, but less than 2. 3 over 8 can be written as 0. In fact, it goes there 4 times, 3 times. You are left with 68 goes into 60 how many times? 7 times. We are left with 45. So this will help us plot easily. If we put the number line there for this joint, we have 0, 1, 2, 3, -1, -2, -3. So 0.3 5 will be somewhere there. And it does not include that. And then we have 2. So we can look at inequalities involving fractions. How's the inequality? So this one is because it is an inequality. It's not an equation. You cannot bring this value on this side. The best way of solving it is by writing it, bringing subtracting 3 from both sides, then getting the LCM of that. LCM of x minus 1 and 1. So that will give us 2x minus 7. And the other one will be minus 3 into bracket x minus 5. Then if we open the bracket, that is less than or equal to 0. Open this bracket, we have 2x minus 7 minus 3x plus 15 is less than or equal to 0. Put the like terms together. We have minus x plus 8 divided by x minus 5 less than or equal to 0. So the way we solve this is we have two values that can satisfy this in equation. X is equals to 8 and x is equals to 5. This equation will be satisfied. But when we have inequalities, we have a range of them. We are looking for the range of values that can satisfy this. So therefore, we have to look for all the values which can satisfy this. And so we will start from negative infinite to 5, then from 5 to 8, then 8 to infinite. Because we are looking for all of them. We're looking for all these values. Array inequality gives us a range of values, not just two values. We're not looking for x and y. It's greater than or equal to. So we'll have negative infinite to 5, 5 to 8, and then 8, 8 to infinite. So we test here when we are looking for the solution within the ranges, we test. Like if you're looking at this first range, we pick a value inside this first range and test whether it satisfies that inequality. Or even this one, the original one. If it does, we know that our value lies here. If it doesn't, then we reject the fact that this cannot be range of values. So we can pick like 0 is within this range. The range minus infinite to 5, x can be equal to 0. So we substitute x in this, we'll have 2 times 0 minus 7 over 2 minus 5. Is it going to be less than or equal to 3? That is what you're looking for. So 2 times 0 is 0. And then you have minus 7 divided by minus 3. No, this is 0, sorry. X is 0. So what we put here is 0. So 2 times 0 and 0 minus 5 will have minus 7. 0 minus 5 is minus 5. And that will give us 1.4. 1.4 is less than 3. It's less than or equal to 3. So meaning that our solution is found in this interval. This interval, we can get our solution. Then we test 5, 8. We test for 5, 8. Can it give us a solution? We pick any value in that interval. We can pick 6. We substitute 6. 6 into our 2 times 6 minus 7. And then we have 6 minus 5. We want to check whether it is less than or equal to 3. 2 times 6 is 12. 12 minus 7 is 5. 6 minus 5 is 1. Is it less than or equal to 3? No, it is not. So our value is not in this range. Our x is not in this range because it does not satisfy our inequality. our x is not there. Because we are looking at a range of values. We are looking at a range of values. When we were drawing our inequality lines, they were not ending somewhere unless it is simultaneous. You see, like this one goes, when you say greater than or equal, it is to infinite, okay? Because it is just greater than that value. Where we have simultaneous, but you see, x is greater than 3. So anything up to infinite is satisfying that inequality. And this one, x is less than or equal to minus 2. Anything to the negative side will satisfy this inequality to up to infinite. So that is why we are using infinite. All those values will satisfy the inequality. So the remaining one we have to check is 8 and infinite. We have to check it in the equation 2x minus 7 over x minus 5 is less than or equal to 3. So we can pick 9, 2 times 9 minus 7, and then we have 9 minus 5. Will it be less than or equal to 2? We have 18 minus 7 divided by 2. Will it be less than or equal to 2? So that gives us 11 divided by 4. Will it be less than or equal to 3? So 4 will go there into 11 2 times. In 30, it will go in 37, 12. So 2.75 is less than, at least it is less than 3. So this also satisfies the inequality. So you have two satisfying your inequality, range negative, infinite to 5, and then this one. These two are called interval solutions. So or solution intervals. So we can also have x plus 6 over x plus 1 being less than 2. Then we can have x plus 6 over x plus 1 minus 2 being less than 0. X plus 6 over x plus 1. That becomes the LCM. So there is 2 here, that 2. Let's not forget this one. And then it is 2 over 1. 1 will go there, x plus 1. You put there x plus 1. Then you open the bracket. Put the like terms together. You have 4 minus x over x plus 1 being less than 0. So our x will be equal to 4, and x will also be equal to -1. You put there 4 and -1, you'll get 0. So our intervals are -infinite to -1, -1 to 4, from 4 to infinite. So we test the range -infinite to -1. You can test -2. You have 2. I have explained that. I have indicated why we are using infinite, my friend. Okay. I have said when we are drawing the line, I have explained that. These lines go to infinite. Okay, this solution is x is greater than or equal to 29. So anything that is greater than or equal to goes up to positive infinite. And then on the other side, we have this one, x is greater than or equal to -2. You see, it goes all the way to negative infinite. So that's why we are using those ranges. The solutions go to infinite. So if you pick 2, substitute, you'll have 2 plus 6 over 2 plus 1. Is that less than 2? Negative, sorry, this is negative. In this range, we have negative. So we have negative and negative. Are they less than 2? So that will give us 4. And that will give us -1. Is it less than 2? Yes. -4 is less than 2. So that is correct. This interval is correct. Then we have the next one, this one. The interval -1, 4. We can pick 0. Our x can be equal to 0. 0 is in that interval. If we substitute here, we will get 0 plus 6. 0 plus 1. Is it less than 2? That gives us 0. Is 0 less than 2? No. So this interval is not there. Then we have 4 and infinite. You can pick 5 and test. These are tests. X is equal to this. Remember, you're using this as for testing. Even this one. So that's, if you substitute there, it is 5 plus 6 and 5 plus 1. We have 12 over, sorry, 11 over 6. That will give you 1 point. 6 goes into 5 how many times? 8, 3. So this is less than 2. So that inequality satisfies. So the solution intervals are those two are the solution intervals by virtue of the fact that if you pick points in those intervals, they satisfy your inequality. So we solve this in a similar way as we have done up there. For example, if we have 2x squared minus x is less than 3, write it as 2x squared minus x minus 3 is less than 0. When we factorize this, we have just learned factorization. We factorize this. If we factorize that, we'll have x being equal to, we are looking for two numbers such that if you multiply them, you'll get 6. 2 times 3 minus 6. If you add them, you'll get minus 1. We find that those two numbers will be So the two numbers will be minus 3 and 2. We have x into bracket 2x minus 3. So we have x plus 1 and 2x minus 3. So our x, remember we have an inequality, less than 0, less than 0, less than 0. So our x values, solution for this is x is equals to minus 1 and x is equals to 3 over 2. But because it is an inequality, we have to look for the range of values. We have to be working with the range of values. Therefore, we have to have a range of minus infinite to -1, and then -1 to 3 over 2, then 3 over 2 to infinite. And the way we test it, we will still test here to check where it belongs. So like in that interval, we'll pick minus. In that interval, we can pick x being equal to -2. And then we test in this or that. We'll have 2 minus 2 squared minus 2. Is it less than 3? So 2 times 4, 8 minus 2. That will give us, is it less than 3? 6, is it less than 3? And we find it is not. So this interval is not an interval satisfying our inequality. Then we have the next interval is that we pick a value from here and test into the polynomial. So we can take x to be equal to 0. If we test in the polynomial, we'll get 2 times 0 minus 0 is it less than 3. 0 is it less than 3? Yes. So this is a polynomial that, a range of values that satisfy our polynomial inequality. The last one, we have 3 over 2. Infinite, we can pick 2. We test 2 into our inequality. We have 2 squared minus 2 is it less than 3. 8 minus 2 is it less than 3. 6 is it less than 3. And we find that it is not. Now this was minus 3 So this was supposed to be plus, but it is still not less than as 10. 10 is not less than 3. So 6 is not less than 3. So also this one is not satisfying. So only one interval, solution interval is -1, 3/2, because it satisfies our So can you try this one? Let me try that one. So this is the one you need to solve. X squared is less than x plus 6. Solve this one. X squared is less than x plus 6. Just use the same method we have used here. You put the message good. You'll be stressed. It's only that now you're also stressed. I hope it will not interfere. But boy, we are solving a sum. So your solution is -8. Where is your test? Where have you tested? That the others are not satisfying. Yeah, this is correct. The ranges are correct. So long as when you factorize, we're looking for two numbers, m times n, which will be equal to 6. You rewrite this as x squared minus x minus 6 is less than 0. So you look for two numbers such that m times n will give you -6, and m plus n should give you -1. So the numbers will be -3 and 2. We have x squared minus 3x plus 2x minus 6 is less than 0. We should, when you're writing this, you need to start from here, because if you don't get the solutions correctly, then this is quite important. You have to factorize this. You have to solve this quadratically. X plus 2, x minus 3 is less than 0. So x is equal to -2, and also x is 3. So from there, now you have these ranges. This is correct. Anyone who has tested, still testing. You are just giving me the answers. Testing, you have to test. Huh? You have to pick these ranges as given. You have to pick the range in, and you show that you tested. Pick a value. Let's see how you solve. The ranges you've given me are negative, infinite, -2. That's okay. And -2, 3. That's okay. 3, infinite. That's okay. So when you're testing here, -8 and -2, you can pick -3. And then you test in that interval, it will be -3 squared. You pick your x as that. Had you done this, we'll not be discussing this, but at least it's a good trial that you know where it is. Should be less than 0. 9 minus 9 should be less than 0. 0 is not less than 0. So this is not right. 0 is equals to 0, but it is not less than 0. So this one is not right. Then we have minus 2 and 3. Our inequality is x squared minus x minus x minus 6 should be less than 0. So we had tested infinite and we found it is not in negative infinite to negative 2. We test here. Here we can pick 0, 0, minus 0, minus 6 is less than 0, minus 6 is less than 0. That is true, and that is true. So that is what you've given for your interval, which is true. Here we can pick 4 and see 4 squared. 4 squared. Sixteen minus 10 is less than 0. 6 is less than 0. That's not true. So this one is not true. So the only solution interval is, as you've said, minus 2, 3. So this is correct. So you can clap for yourself, that is correct. I'll give you one you try at home. Yes, what are you differing about? What's the problem? Louis, what are you differing? Hmm? Why are you differing with Louis? What do you want to say? There's a reason why I mute you. Because if I don't mute you, you make noise. Yeah. And we are recording this. Yes, tell us. Louis?
Yes, hello.
Yeah.
Yeah, now my deferment comes from the ISO M and N. I think it should be -3 and +2. Does it later -x? Because when you use +2, when you use +3 and -2, the value of x in the equation will be positive, but we have it as negative.
These are the solutions. When we are looking at the equation, it was negative.
So we use the original equation, not the one after we've equated them to 0.
You see, what you're saying is we use positive x, we use positive 2, positive 3.
Yeah.
But if you put positive 3 here, you'll get positive here, and this is negative.
Okay, fine.
So I'll give you one you solve at home.
Unmute kwanza.
Solve the cubic, it's a cubic equation, cubic inequality. This is a cubic equation. We solve the cubic one. I'll give you a hint. Just do what we have done. Rewrite it. Bring 12x on this side, greater than or equal to 0. Then you factorize by removing x out of the bracket. X is common. So what you're left with inside here is a quadratic equation which you can factorize. It will have 3 factors, 1 coming from this one and 2 from here. So when you're writing your intervals, they will be 4, not 3. Starting with negative infinite to positive infinite. There will be 4 of them. So factorize this, those then you have 3 factors as opposed to 2 for quadratic. When we solve them, like we test the way we have tested and find the solution intervals. So we can stop there. Faith. Yes, Faith. Yes, you cannot speak. Yes, Faith.
Yeah. Okay, my question is,
Yes.
in that question that you have done in getting the solutions intervals,
Mm.
the first question that we did with you, you used less than less than 3 to find the solutions interval, and in this other question you have used to solve where there is less than 0.
Yeah, you can use either. You can use either.
Or either.
Yeah, they'll just give you the same answer.
Okay, for me, when I've used that one for with less than 6, I've gotten the solutions interval 2. I've gotten 2.
Two.
Yeah.
You see,
The negative, yeah?
the solution interval are a range of values.
Mm-hmm.
Yeah. So if you used 2, you picked it from the range we have. Used. Yeah. So whether you use what I used or not, when you're picking this,
Okay.
because the correct interval is this one. Your 2 is still here. Yeah.
Yes. Also, me, I've gotten negative 2 and 3, and also that one for the negative infinite and negative 2, I've also gotten it.
You can just check. You see, you'll have x squared. You have x squared minus x is less than that was the original equation. Yeah.
Yes.
So the negative one has which values? The negative infinite has which values? It had the values. We picked -3. Yeah.
For me, I picked -1.
-1 is not here.
Oh, it is not there. Okay, I've seen where I went wrong. Thank you.
-1 is not here. Is here.
Oh,
-1 is greater than -2. Okay. But
yes.
if we picked -3, let's see whether -3 still gives us right and a similar answer. We have, so we have the range -infinite and -2. So we pick our x to be equal to -3. This will give us a squared minus -3. Okay. This will
Yes.
give us 9.
Plus 3.
So 12 is not less than 6. So you see, we rejected it, and it is true. Even if you used this one other than 0, it just still gives us the same thing. Okay. So it does not
Yes.
which one you use. It will give you the same result.
Yes.
So that's okay. I hope you have been able to reconcile that. Okay.
Tukatuacha tulikuwa tusema tutatoka class
So we can stop there. I think for today, ensure that you look at this the way we have done. And you can meet next time. Bye.